Good afternoon. Today we will move on to the last unit, durability and mixed design. So far as we seen in first unit cement and admixture, second unit aggregates, third unit fresh and hardened properties of concrete, fourth unit non-destructive testing and engineering properties such as shrinkage, creep and this elastic modulus. Now in fifth unit we will see about okay the durability and the mixed design. So what is meant by durability? So many of you are thinking that durability is a property. It is not like that. It is nothing but a performance of a concrete structure in its service life under the exposure condition. So how the concrete is performing okay in its service life when compared to an exposure condition. So I will tell you an example for it. You make a concrete cube, okay, two concrete cube in the same medium, in the same mannerism. You are making the concrete. One concrete you are keeping inside the room, another concrete cube you are placing the in open environment. So what will happen after 10 years if you examine that concrete cube? Means the cube which is placed inside the room okay will be of more durable when compared to the concrete which is placed outside. Okay, it will have some damages okay when compared to the concrete which is placed inside. Okay, why? Means its exposure condition is different. Inside the concrete the amount of rainfall or the exposure to the heat, okay, sun rays, okay, and everything will be different when the concrete is placed inside the room. Okay, so and what is meant by service life? Service life means it is the concrete where okay it is doing its performance okay in its lifetime. So that is called service life. Okay, so and performance required means, see, normally for design point of view, concrete performance will be calculated with its load carrying capacity, but actually it is not sure. Not only the load carrying capacity, the signs of distress, deterioration happening, and the aesthetic view also is very important. You can see this picture. Okay, so on the picture which is on the left hand side okay is not aesthetically good. It has a lot of moisture, that is dampness in that. So due to that the algae has grown. And if you see the this right hand side picture, okay, what you can see aesthetically it is very pleasant, good. So which house you will prefer? Okay, the house okay which is aesthetically good only. So it is not only the load carrying capacity but also the aesthetic view also very important. This one is a drainage tunnel. Here you can see lot of damages has been there. So when compared to this one, this tunnel is good. Okay, so we should not always focus on the strength point of view. Okay, the aesthetic point of view and the signs of distress also we should take into account. Okay, so only it is called as performance of the concrete in its service life. Okay, so with this understanding we will see the definition as per the IS code 456. Okay, durability is defined as the concrete which is satisfactorily performed in its service life okay and for the working environment for the various exposure condition. Okay, so how the concrete is performing okay in its service life when it is exposed to various environmental condition, that one will be the definition for the durability. And in another simpler terms, if it tell means you consider a concrete how it resists to the weathering action, chemical attack, abrasion and other process of deterioration without altering its original form. That is very important. Okay, and its quality. Suppose a concrete is there, okay, you are making a building, okay, the concrete used for the beam in that building is M20. After 25 years whether the strength is same. Okay, initially the concrete strength is somewhat 20 MPa means after 25 years the concrete strength is 25 MPa means then okay it is called a durable concrete. But due to the environmental condition okay and other factors, the concrete performance will be decreased in its service life, and thereby the strength will be somewhat less only. Okay, in maximum cases. Okay, if you are doing a proper maintenance other thing means you can expect it okay to the original strength. Okay, So in severe environmental condition means you can see most of the concrete okay will undergo some mainly this drainage pipeline. Okay, so there will be lot of acids will be used. So this hydrogen sulfide gas will be formed. It will be deposited onto the surface of concrete. Thereby acidic environment will be created, pH will be less, and it will try to leach out the concrete surface. Or if you are constructing a building near an agricultural land where it is subjected to sulfate attack, okay, concrete will be converting into powder, because in agricultural land they will use lot of fertilizers are nothing but ammonium sulfate. So the sulfate will directly attack the concrete, and it will try to react with the hydrated cement paste, and it will convert into powder. So the foundation which you have constructed in this agricultural land will be converting into powder. Thereby the structure has a possibility of failure. Sometimes this type of alkali silica reaction also will happen. Alkali aggregate reaction, if you say poor quality aggregate and the cement whose alkali content is more also, this type of problems will create, expansion will happen. So as per the IS 456, they have told about the exposure condition. So it is classified as mild, moderate, severe, very severe, and extreme. Mild case means, so we can see about okay a normal region where it is away from the coastal region. Moderate means okay so it will have some severe rainfall, freezing, and other cases. Severe condition means okay it will have alternate wetting and drying, okay, and freezing also will happen. Very severe means when a concrete is exposed to a seashore, okay, sea water spray close to the seashore means this will be considered as an very severe condition. Extreme condition means this tidal region where the sea waves will continuously hit the concrete surface, and mechanical forces okay will be created by the sea waves, and damages will be more. Or any liquid or aggressive industry where okay consider a chemical industry where a hydrogen uh, okay, or a sulfuric acid or hydrochloric acid is prepared, okay, that and all aggressive environment. So that is considered as extreme cases. So based on the environment, the exposed condition has been already listed out. Okay, so what are all the causes for the lack of durability? So we will see this under two cases. One is external, another one is internal. External means this weathering condition alternate in daytime, okay, temperature will be more, night time the temperature will be less. Extreme temperature condition, okay. Humidity, so humidity if it is more near an okay hilly region means always it will have more amount of humidity in air, okay. So always the concrete will be wet in condition, so then the algae will go and it will try to uh, degrade the strength of the concrete. Abrasion, so you consider a okay road where the traffic is more, the surface concrete will be abrated, okay, and attacked by some industrial liquid gases, hydrogen sulfide gas in a closed concrete okay sewer pipe. So that and all okay will be considered under external causes. Internal means some okay physically means there may be some volume change. Suppose if the property okay aggregate will have okay a coefficient of thermal expansion, okay, if more amount of temperature is there means it will cause the expansion of the aggregate or the cement paste, thereby crackings will be formed. This is about high temperature. Low temperature means freezing will happen. Water if it is locked inside the concrete means pore spaces of the concrete means it will try to okay expand, okay, when it freezes means then okay some pop out will happen. And chemically means about that alkali aggregate reaction. Whenever a reactive aggregate and the alkalis in the cement is more means in the presence of water and in favorable condition of temperature, it will react and it will form a gel, that is called alkali silica gel, okay, surrounding the aggregate okay border, and finally it will try to swell, result in map cracking, okay. Or sometimes corrosion of steel also will happen, okay. This we already studied. Corrosion of steel means due to the entry of water, air, or some chemicals like chlorine, so thereby the passive layer will be disturbed and its pH will be reduced, and the rusting of the steel bar will happen. Once the rusting happen, what will automatically formed? strains will be formed in initial stage, and in second stage cracks will be delamination will happen. Okay, cracks, after the delamination, after that spalling will happen, and the reinforcement will be totally exposed to environment, and at final stage there will be no reinforcement to take care of the tensile load, and building will collapse. Okay, so these are all the causes. And what are all the factors which affect it? So the main factors, okay, are the cement content. Suppose if we increase the cement content, what will happen? Automatically the pore space, okay, will be reduced. So thereby, okay, if the strength is more, means automatically the durability will be more. Okay, if the cement content is less, then what will happen? Okay, it will have a lot of pore space in that, and okay, the strength of the concrete will be less, means then durability will be less, compaction. So as I told, this pore space, okay, we should make a denser concrete, so compaction is very important. If you are not compacting the concrete properly, okay, what will happen? It will result in the air bubbles formation, thereby easily this air and water will enter, and the corrosion will try to start, so the durability issues will happen. So next one is curing. So mainly curing is also plays a major role. Okay, why we should do curing? To uh, make the concrete to achieve its target strength. If you're not doing the curing, what will happen? The water which is meant for the hydration process will try to evaporate out, and thereby the desired strength cannot be achieved. Okay, so there are many methods of curings, as I told it, like water curing, membrane curing. Okay, or sometimes the steam curing also can be given, infrared rays also can be sent. So that are the different methods of curing based on the conditions, okay, or the environmental condition which is available. So if you're not doing proper curing, proper strength won't be attained, thereby durability will be affected. And next one is cover depth. So if you increase the cover depth, means what will happen? The possibility of this air and water from the outside environment to reach the reinforcement will be delayed, so thereby the corrosion can be prevented and concrete will be durable. Okay, so you may know about the concept. For example, slab means they will provide 15. Okay, beam means the cover depth they will minimum they will provide 25. Column means they will provide 40. Foundation means 75. So there is a purpose for that. Why? For the ceiling slab is 15, means it is not directly exposed to the outside environment. Okay, so corrosion won't happen. And in case of beam also, the outside face will be exposed to the environment. So what will happen means, so only the cover depth is 25. So from the outside face the water may try to enter. Likewise similarly for column also. So column for the full length, so one side fully will be exposed to the outside environment, so only the cover depth for it, it's 40. When we compare to foundation, so during the rainy season means the water table will try to raise, and the foundation is having a chance of submerging into the water, so only we are providing a cover depth of 75. So cover depth plays a major role for durability. And last one is permeability. So if the concrete is more permeable, what will happen? Automatically the durability will be less, easily water is passing through that and it is coming out, so it will cause the corrosion. So these are all the factors which affect the durability of the concrete. So next class we will see about permeability. Thank you.